Hello, everyone, and welcome to my session, Deploy N Applications to N Clusters using Argo CD application set. My name is Dewan Ahmed. I'm a developer advocate at Red Hat, and I'm from the beautiful New Brunswick in the Atlantic Canada region. I love everything cloud native with a focus on DevOps and GitOps tools. Besides work, I love to play pool and ping pong, and I'm also a freelance career coach. I help students, new grads, and professionals to start or transition into the software industry. We have a packed agenda today. I'll cover some highlights or ideas behind GitOps. Then I'll go over Argo CD. Although this session focuses primarily on ApplicationSet, I understand that some of the folks might be very new to Argo CD. So a quick primer with Argo CD will be helpful for them. We have a demo for both Argo CD and ApplicationSet. At the end, we'll have a Q&A session, and all the resources are in the GitHub repository, which you can see at the bottom right corner of your screen. If you're watching this session on a mobile device, you can scan the QR code, which will take right into the GitHub repository. So let me quickly show you the repository real quick. So this is the repository which will need you to have either the slides or the recording so that you can follow along. Now the slides are added under the slides folder, and the prerequisites and the steps are mentioned here. This demo on this GitHub repository uses vanilla Kubernetes, and the session will use OpenShift GitOps, which packs Argo CD and ApplicationSet. But you're free to use either, or you can use either vanilla Kubernetes cluster, you can use OpenShift. The resources are right here at the very bottom of this repository, and you can refer to those for either GitOps or Argo CD getting started or ApplicationSet. All right, so coming back to the presentation, who came up with the term GitOps? Alexis Richardson, the current CEO of Weaveworks, he came up with the term GitOps, and he ran it by his friend. His friend thought that's the ugliest word he ever heard, and now he can't unhear it. Trying to come up with a term that is easy to pronounce, but also difficult to forget, Alexis realized that he found that perfect term. Now, this slide is from Luis Facira, and it summarizes GitOps in one slide. So we use Git as the single source of truth of a system. We use Git as the single place where you operate. We don't operate directly on the cluster. We use Git to do any create, update, or destroy of environments. All the changes are observable and verifiable. So keeping that in mind, let's understand GitOps. Scratch that. Let's understand GitOps for Kubernetes. So Kubernetes gives us the power of declaration. That means everything in Kubernetes model you can describe declaratively. Kubernetes updates provide a mechanism for automating the process of applying a set of changes directly, correctly, and in a timely manner. Kubernetes will try to keep updates until it succeeds, which is convergence. Idempotency means that multiple applications trying to converge will always have the same outcome regardless of how many times you're applying the command. And finally, for determinism, assuming that you have adequate resources, the updated cluster state depends only on the desired state. So you should avoid using kubectl to update the cluster, and especially avoid using scripts to group kubectl commands together. Instead, use a GitOps tool so that the user or developer can update their Kubernetes cluster via Git. So what does that provide us? That provides us correctness. That means a group of updates may be applied, converged, and finally validated, which gets us closer to the goal of atomic deployment. provides us security. So we should limit the scope of access to a Kubernetes cluster to automation tools and cluster administrators who may have to debug it or keep it running. And that's a tweet by the famous Kelsey Hightower. Finally, kubectl exposes the machinery of Kubernetes object model, which is quite complex. Ideally, your users or developers should interact with the system at a higher level of abstraction. So based on our discussion so far, these are the parts or bill of materials that we need to do GitOps on Kubernetes. First, we need the Git repos where the configuration code lies, and we need Kubernetes cluster or clusters where you'd like to deploy your code. Then you need some sort of manifest generation tools like Kustomize for different environments such as dev, pre-prod, prod. This is optional, however. Then don't use a CI server to orchestrate direct updates to Kubernetes as a set of CI jobs. Now, I added a link in the resources section in the GitHub repo that goes much more in details why you should not use CI servers to do CD. Finally, your Kubernetes manifest files are needed, such as deployment services, etc. So keeping these in mind, if we're looking for a GitOps tool, Argo CD is an ideal choice. So what is Argo CD? Argo CD is a declarative GitOps continuous delivery tool for Kubernetes. It is part of an open source project which has contributors from both small and large companies like IBM, Red Hat, Intuit, as well as many individual contributors. This project has also been adopted by a number of companies, and you can find a list of that companies under the Argo CD's GitHub repository. So why Argo CD? So the first 3 points have been covered before, where we use Git as the single source of truth. It's being developer-centric, where you use Git commands to make any updates to your application delivery, and being declarative. Now, let's talk about security. So Argo CD provides SSO integration, including OIDC, OAuth 2, and more. It provides multi-tenancy and RBAC policies for authorization. It also gives audit trails for application events and API calls. You can roll back your deployment to any application configuration committed in Git repository, either using the CLI or the UI. Argo CD app diff, the command, that performs a diff against the target and live state. So you can observe the drift, and that can be done by the UI as well. So all these features and many more help your engineering teams to have a higher velocity in terms of their application delivery. So this is the Argo CD architectural diagram, which is from the Argo CD Read the Docs webpage. So here, the blue box in the right-hand side is the Argo CD. So Argo CD is implemented as a Kubernetes controller, which constantly monitors running applications and compares the current and live state against the desired state as specified in the Git repo. A deployed application whose live state deviates from the target state is considered out of sync. The API server, which you can see right here, where I hover my mouse, is a gRPC and REST server, which exposes the API consumed by either the web UI or the CLI or the CI/CD systems. Now, the repository server, which you can see right here, is an internal service which maintains a local cache of the Git repository holding the application manifests. Now, the synchronization can be done using sync hooks, and you can have different use cases to perform these pre, during, or post sync. One use case of such sync hooks could be if you want to orchestrate a complex deployment, which requires more sophistication than the typical Kubernetes rolling update strategy, you can do that. And on the bottom, right, you can see your application being deployed into many clusters. All right, so enough theory. Let's dive right into the Argo CD demo. So for this demo, what I have is an OpenShift cluster, and we installed Red Hat OpenShift GitOps operator on this cluster. So this operator gives us out of the box Argo CD instance. This is the Argo CD instance, which I connected to. Let's create an Argo CD application. So this is my application manifest. So I'm going to deploy a customized guestbook application, which has a deployment file, a service file, and a customization file. So let me copy the link of this, this configuration repo. So I can do that from CLI as well, but I'm choosing to use the UI to create this sample application. I can give it a name, let's say a DevConf demo. I'm going to choose default project, which is Argo CD project, and not your Kubernetes namespace. For sync policy, I'm going to choose automatic sync. I'm going to check these two, which says Argo CD will prune resources if they're no longer in Git, and self-heal means if I make any changes directly on the cluster rather than Git, Argo will force and override the changes I'm making directly on the cluster and will have the state defined in Git reflect onto the cluster. So the repository URL is the URL I just copied, and the path is customized-guestbook. So it should automatically pre-populate customized-guestbook right here. This is the cluster URL is on the cluster where Argo CD is deployed and not the remote cluster. So this is the default service. The namespace, so you can deploy the application on the same namespace, which is Argo CD, where Argo CD is installed, or you can choose a different namespace. So on OpenShift, what I did was I created a namespace called guestbook-devconf, and I added a small label, which is managed by OpenShift GitOps. What this allows is OpenShift GitOps controller to make changes in that namespace. So since I already have it, I can deploy into the guestbook-devconf namespace. So let me choose that, guestbook-devconf. All right, looks good. I'll add a prefix, let's say XYTC dash, and create. So once I create, since I have auto sync enabled, you can see that your application was deployed. It creates the service and the deployment. And if I see my deployment.yaml, I can see I have 3 replicas, and you can see 3 pods. And how about if I make any changes? If I change this, of course, you should do a proper PR process. But for this demo, I'm making change directly to the main. So if I commit the change, let's see what happens to my application. Once I make this change, let's hit refresh. We should see the application goes out of sync. But since I have auto sync enabled, the state of the cluster will be matched to the state defined in Git, which is a single replica. And you see the number of pod went down from 3 to 1. I can delete my application. So if I hit delete, devconf-demo, and here I have deleted the application. So that was the quick demo of Argo CD. So let's go back to the presentation. Now that was all nice. We deployed a single application to a single cluster. But what if we want to deploy Argo CD application to multiple Kubernetes clusters at once? Or how about deploying multiple Argo CD application from a single mono repo? Introducing ApplicationSet controller for Argo CD. So on the left of the screen, you can see that ApplicationSet controller is sitting in the middle, and it's looking over your Git repositories, and then it's creating multiple Argo CD application across multiple clusters. So unlike Argo CD application resource, which deploys resources from a single Git repository to a single destination cluster or namespace, ApplicationSet uses templated automation to create, modify, and manage multiple Argo CD applications simultaneously, targeting multiple destination cluster and namespaces. So the application set controller is installed alongside Argo CD within the same namespace. That means on your cluster, you have to have Argo CD installed first on the Argo CD namespace, and on the same namespace, you install application set controller as well. So in this example, you can see on the right-hand side of the screen, in this YAML line number 2, shows the kind being application set. The list generator passes the URL and the cluster fields into the application template as parameters. So if you see line number 11 and 12, the URL and cluster, these are going into the template, which is basically an Argo CD application template. And on line number 21, you see that there's cluster value which being renders. And then on line number 29, you can see the URL value being rendered into the template. Now, targeting new clusters is simply a matter of you just add new elements into the application set resource, and the corresponding Argo CD application would be automatically created. How does application set controller work? Now, the sole responsibility of the application set controller is to create, update, and delete application resources within the Argo CD namespace. The controller's only job is to ensure that our application resources remain consistent with the defined declarative application set resource, nothing more. Thus, the application set controller does not create, modify, or delete Kubernetes resources other than the application CR. It does not connect to cluster other than the ones Argo CD is deployed to. It does not interact with namespace other than the one where Argo CD is deployed within. It is Argo CD itself that is responsible for the actual deployment of the generated child application resources, such as deployments, services, and config maps. So the application set controller can be thought of an application factory. So it takes an application set resource as input, which you can see from the Git icon right here, and outputting one or more Argo CD application resources that correspond to the parameters of that set. So application set has a number of generators, list generator, cluster generator, Git generator, and some of the recently added generators in this list. But for the demo, we'll cover only a few of these generators, starting with list generator. So if you want to check out these generators in much more detail, you can go to the read the docs for application set. So for now, I'll come back to the presentation. And it's time for application set controller demo. All right, so let me start the demo. So here I have the application set list generator demo. So if you see for the list generator, the type is application set, and in the spec, we provide the generator type as list. And here you add your local and remote clusters. And based on the template definition of the application, your applications will be divided into, your application will be deployed into n number of clusters, which are defined here. So coming back to the demo. So this is engineering dev, which is the local cluster where your Argo CD is installed. So if I go to cluster, I can see that both of the clusters are there because I did an Argo CD cluster add to add the engineering prod cluster already. And here in the source repo URL, you can see the application which we're trying to deploy. So the manifests are in that source repo URL. It also shows the path. So similar to the guestbook application, which was customized / guestbook, it also has that example path for that application. So you can create ApplicationSet directly from the OpenShift console. So once you create, you can go back to the Argo CD UI, and you can see that 2 apps are created. So if you see the destination right here, this app is in cluster, but the other app is deployed into the remote cluster. So if you see the local app, which was deployed locally, was healthy and synced, but the remote app, it failed. So if you click on sync failed, it says the namespace is not found. That means in the remote cluster, we did not create the namespace. So we created the namespace, and that's something I showed you earlier as well, that the namespace has to exist before you create the application. So I created the namespace now, and now let's try to sync one more time. So if you click synchronize, the application deployed into the remote cluster will sync as well. All right, so it looks like both of our applications are now synced. So this was using ApplicationSet list generator example. Now, let's try to delete this application. So let's say someone is being adventurous and trying to delete resources directly on your Kubernetes cluster. So what will happen? Since it's deployed using ApplicationSet, this change will be reverted. So you can see on the left, the application quickly became out of sync because it was deleted. But because you created these applications using ApplicationSet, you can see the application, Argo CD application is again being created. So which is different than if you created an application using Argo CD, you could directly delete from Argo CD UI. But because you created using Argo CD ApplicationSet, even if you delete from the UI or from the CLI, because it's created and managed by ApplicationSet, the applications will be created again. So that was a quick demo of Argo CD ApplicationSet list generators. So going back to the presentation, you can try out the different generators which are in this demo right here. So in this demo, I went over some of the other types of generators, which are Argo CD ApplicationSet Git generator, and also the matrix generator. So that you can try out on your own. So at this time, I'd like to thank you for attending my sessions and welcome any questions you might have.